Every time you click buy, like on a custom order, a factory somewhere has exactly, I don't know, 300 milliseconds to do the math on a million different physical constraints before just confidently flashing delivery next Tuesday on your screen.
Right, yeah. And you just expect the physical world to behave exactly like software.
Exactly. You click, it compiles, and it arrives. But the reality is, we are relying on these massive systems that prevent these manufacturing operations from practically bursting into flames under the weight of their own promises.
Which is why the illusion of, the infinitely stocked warehouse is so comforting for us. As buyers, we really don't want to think about supply chain bottlenecks or like machine maintenance schedules.
No, we just want our custom electric mountain bike.
Exactly. We just want to buy. But to guarantee that delivery date, a manufacturer is running this incredible gauntlet of complex mathematical filters. They're constantly testing material constraints against human labor, against machine availability, and all of this while orders are just firing in at totally random intervals.
And that is exactly what we're getting into today. Welcome to the deep dive, everyone. We are going to explore the hidden mechanics of how those custom things actually get made and delivered to you on time.
It's a fascinating process.
It really is. Our mission today is to unpack 3 critical pillars of manufacturing supply chains that make all this possible. We're looking at capacity requirements planning, which is known as CRP, available to promise calculations, or ATP, and final assembly scheduling, the FAS.
Right, and we're specifically looking at how these 3 distinct layers act as, sequential reality checks.
Sequential reality checks, I like that.
Yeah, they're basically the mechanisms a company uses to drag a theoretical business plan down into the physical reality of the factory floor.
Because theory and reality are very different things in a factory.
Oh, completely. So first, they're verifying if they have the physical muscle to actually build something.
Yeah.
Second, making a binding mathematical promise to you, the customer. And third, orchestrating that final chaotic sprint to the shipping dock.
Right. Okay, let's unpack this. Let's start with that first filter, the CRP. Because before a manufacturer promises you anything, they have to know their absolute limits.
They have to.
So if a company already has a material requirements plan, an MRP, which, tells them exactly how many rubber tires and aluminum frames they need, where does capacity requirements planning even enter the picture?
Well, the material plan is really just a shopping list. It assumes you can actually, cook the meal.
Okay, right.
CRP sits right alongside that material plan to provide a rigorous physical reality check. It takes that shopping list and asks the hard questions about your factory's specific resources.
Like what kind of hard questions?
Like calculating the required load using your routings. And routings are the literal physical path a part takes through the factory. It combines that with your standard hours, which is the benchmark time it takes a worker or a machine to complete one specific operation.
Ah, I see. So if the material plan says we need 10,000 rubber tires by Friday to meet our monthly goal, the CRP is the system looking at the actual tire mounting work center.
Exactly.
And realizing that specific machine can only output like 1,000 tires a day, meaning the Friday goal is just a physical impossibility.
Right, exactly. CRP continuously loops through all this data. It calculates the total load based on those standard hours, simulates the scheduling at specific work centers, and generates these things called load reports.
And I imagine those are pretty dense reports.
Oh, yeah. They're highly detailed visualizations showing exactly where your bottlenecks are going to be, say, 3 weeks from now.
Oh, wow. So it's looking into the future.
Yeah. It forces the human planners to resolve those load capacity imbalances way before they prepare the final operating plan. So you might see a bottleneck and realize you have to schedule overtime or shift workers around or even outsource a component.
I'm picturing this, it's kind of like planning a cross-country road trip. The material plan is your map and your fuel budget.
Right.
But the CRP is calculating whether your specific 4-cylinder engine can actually handle the steep incline of the Rocky Mountains while carrying 4 passengers and a trunk full of heavy luggage.
That's a great analogy. And if the CRP indicates the engine will overheat, you have to change the parameters of the trip before you even start driving.
You can't just hope for the best.
Exactly. It's an essential long-term simulation. And today, we're seeing CRP heavily integrated with demand-driven MRP systems, or DDMRP.
Demand-driven, meaning it reacts to what's happening right now.
Yeah. Instead of just chasing these highly volatile forecasts, DDMRP sets up strategic inventory buffers. And then the CRP analyzes the capacity needed to maintain those specific buffers, which really smooths out the chaotic spikes in production requirements.
Okay, I'm going to push back on this, though, because any system attempting to model the chaotic physical world has to have a blind spot. I mean, nothing's perfect. What is the fundamental catch with how CRP calculates this load?
What's fascinating here is that CRP's biggest limitation is completely counterintuitive. Traditionally, the core CRP math relies on an assumption called infinite loading.
Wait, infinite loading. We're talking about finding our physical constraints, and the system just assumes we have infinite capacity. That makes no sense.
I know it sounds totally backwards, but it's a necessary mathematical compromise.
Why?
Because if you attempt to calculate exact finite machine availability simultaneously with the dependent material requirements for, say, a product with 10,000 subcomponents, the math just loops endlessly.
Oh, so the computers would just crash.
Pretty much. You create an impossible computational load.
Right.
So CRP isolates the variables. It pretends you have unlimited capacity on any given day, and it just stacks all the required work onto the exact day the material plan says it needs to be done.
Meaning the software will literally output a report that says, hey, you have 40 hours of machining work scheduled for this single machine on a 24-hour Tuesday.
Right. It isolates time from capacity to give you a raw, unfiltered picture of demand against your factory.
Just giving you the bad news straight.
Exactly. It relies on human planners or incredibly advanced finite capacity scheduling software to look at that impossible 40-hour Tuesday and physically smooth it out across Monday and Wednesday.
Got it.
Because of this massive data requirement and the infinite loading assumption, CRP is strictly a planning tool. It spots the icebergs weeks in advance, but you do not use it to manage your minute-by-minute daily operations.
Okay, so what does this all mean for the listener? We run our CRP, we've smoothed out our impossible Tuesdays, we know our overall capacity limits.
Well,
But the person on the phone closing the sale with the customer isn't looking at a master capacity load report. They need a fast binary answer like, can you get this to me next week, yes or no?
right. They don't care about standard hours.
Exactly.
Yeah.
And this is where available to promise, the ATP, takes over, right? Transitioning from internal reality to external commitment.
You nailed it. ATP is the firewall between the factory floor and the sales team. It calculates the uncommitted portion of your inventory and your planned production.
Uncommitted meaning nobody else has laid claim to it yet.
Exactly. It exists in the master schedule for one sole purpose, to support customer order promising so you never, ever sell the same bicycle twice.
Okay, here is the detail in the sources that completely threw me. The ATP calculation intentionally ignores constrained demand.
Yes.
Like, it completely ignores the company's internal forecasts and strictly focuses on actual, firm customer orders. Wait, ignoring the forecasts.
It does.
These companies spend tens of millions of dollars on predictive analytics and AI demand forecasting. You're telling me the moment a customer wants a firm date, the system intentionally blinds itself to all that expensive predictive data.
It does, but it intentionally blinds itself to avoid a mathematical trap called double counting.
The bubble counting. Okay, explain that.
So think about it. If you subtract your forecast from your available inventory, and then you also subtract the actual customer orders as they come in, you're penalizing your inventory twice for the exact same demand.
Ah, I see. Because the actual customer order is the realization of the forecast.
Exactly.
So if I forecast I'll sell 10 bikes and then someone actually buys 10 bikes, if I subtract both, the system thinks I'm down 20 bikes, which is totally wrong.
Exactly. You'd be turning away customers when you actually have bikes in the back room. The forecast is vital for ordering raw materials months in advance. But by the time a sales rep is looking at ATP to close a deal today, the company only cares about cold, hard reality.
What's physically there?
Right. What do we physically have sitting on shelves? What is definitively coming off the assembly line next week? And what is already legally promised to another human being? The forecast is irrelevant at the exact moment of making a binding promise.
That makes a lot of sense. That makes the math surprisingly grounded.
Very grounded.
But the execution of that math varies, right? The literature breaks down two primary ways to run these numbers. You've got discrete ATP and cumulative ATP. Walk me through how discrete handles a complicated timeline.
So, discrete ATP calculates availability in isolated buckets of time. For the very first period, it takes your physical on-hand inventory, adds any finished goods coming out of production during that specific period, and subtracts all the customer orders due before your next production run.
Okay, makes sense.
But the true genius of discrete ATP happens when the sales team overpromises in the future.
Okay, let's put numbers to it so I can wrap my head around it. Let's say in week 1 we have 10 units available.
Good.
In week 2 we have a production run that gives us 20 units. And in week 3 we have 0 production scheduled, but a massive order for 15 units unexpectedly drops. So week 3 is now at -15.
Right. If week 3 goes to -15, the discrete ATP system silently reaches back in time.
Reaches back in time.
Yeah, it pulls availability from the prior period to cover the deficit. So it takes that -15, reaches into week 2's bucket of 20 units, and reduces it to 5.
Oh, wow. So a sales rep logging in during week 2 thinks they only have 5 units to sell, completely unaware that the system basically hid 15 units from them to protect that massive order dropping in week 3.
Exactly. It protects the future by artificially restricting the present. That's discrete ATP.
That is incredibly clever.
It is. Now, cumulative ATP takes a different approach. Instead of isolated buckets reaching backwards, it keeps a continuous rolling total of what's available. And within cumulative, you have a critical divergence. You calculate it either with look ahead or without look ahead.
And reading the sources, the without look-ahead method seems incredibly risky.
Oh, it is.
You're just rolling your inventory forward period by period, but you are only subtracting the orders due in that exact current period. That feels like a disaster waiting to happen.
It is risky. Using cumulative without look ahead is, well, it's like checking your bank account balance, seeing $1,000 and spending it today, completely ignoring the fact that you have an $800 rent check clearing in 3 days. Yeah. A huge order sitting in week 4 will not impact what the sales rep sees as available in week 2. They will sell the inventory, and by week 4, you default on the order.
You just bounce the rent check, which is why cumulative ATP with look ahead is the standard for complex environments, right?
Yes, absolutely.
It still rolls the total forward, but it scans the horizon and actively subtracts all orders scheduled before the next major production run. It sees the rent check coming and essentially freezes those funds in your account.
Precisely. And for you, the listener, understanding this mathematical nuance is really key because ATP is the only mechanism preventing the absolute nightmare scenario of overpromising.
The dreaded back order.
Exactly. It manages customer delivery expectations. It systematically holds products before delivery so they don't get shipped to the wrong client. And it provides the earliest possible warning about component shortages. Without a rigid ATP rule, a delivery date is honestly just a salesperson's fantasy.
Okay, so here's where it gets really interesting. We have verified our long-term physical capacity with CRP. We have made an ironclad, mathematically sound promise to the customer using ATP. Now, the order actually drops. The factory floor actually has to build the custom product. We're entering final assembly scheduling, the FAS.
And FAS operates under entirely different rules.
How so?
It is specifically designed for make-to-order and assemble-to-order environments. If you're manufacturing thousands of identical rolls of paper towels to sit on a grocery store shelf, which is a make-to-stock environment, you don't really use FAS.
Because everything is exactly the same.
Right. In a custom environment, the final assembly schedule is never triggered by a forecast. It only begins after the firm customer order is received.
It sounds like the final staging area at a high-end restaurant. You prepped all the ingredients, you chopped the onions, but you don't fire the dish until the specific ticket comes into the kitchen.
That's exactly what it is. And when that ticket comes in, there are 5 specific steps the FAS takes. First, collecting the order specifications.
Which is really about validation, right?
Yeah.
Can we actually build this weird combination of a carbon fiber frame with heavy-duty cargo tires?
Exactly. And more importantly, is this specific configuration profitable? Because customized options can easily introduce massive inefficiencies.
Oh, I'm sure.
So once you validate the order, you move to step 2, determining required capacity. But here's the thing. You don't run a massive computationally heavy CRP simulation again. The order is here, you need to move. You use rough cut capacity planning or RCCP.
And how does a rough cut mathematically differ from the detailed CRP we talked about earlier?
Well, detailed CRP looks at every single operation, every minor subassembly, and every secondary work center. Rough cut capacity planning ignores the minor details and strictly isolates your bottleneck or critical resources.
Okay, so it's just looking at the big hurdles.
Right. It doesn't check if the workstation putting the grips on the handlebars is free. It only checks if the massive curing oven, which is your known constraint, has available capacity right now.
Okay, that makes sense. So after we clear the bottleneck check with RCCP, What's step 3? I assume the floor workers have to physically go gather the required subassemblies.
Yes. Step 3 is determining components. It's the staging phase. You physically pull the required base components from inventory. Then step 4, you develop the actual final assembly schedule itself.
The actual timeline.
Yes, you sequence the specific operations, you detail exactly what gets bolted on first, what gets painted last, and establish the forward or backward timeline for the floor workers.
Got it. And the final step.
Step 5 is linking FAS to the MPS, the master production schedule. It's an optional step, really just to validate that your immediate floor priorities haven't misaligned with the company's big picture financial goals.
And obviously, visualizing how these custom components flow through a factory floor during all this is critical.
Oh yeah, spatial awareness is huge.
Right, because if you were an aerospace manufacturer, you are dealing with an A-shaped flow, right?
Right.
Millions of raw materials converging into a single airplane. Or a V shape, like an oil refinery, where one raw material splits into hundreds of products. But how does FAS handle it when the physical shape of your production unexpectedly shifts due to weird custom orders?
You're referring to VATI analysis, VATI. And unexpected shifts in those shapes are exactly what FAS planners are desperately trying to prevent.
Okay, so break that down for me.
Take the T shape. It's
Yeah.
classic assembled order. You have a straight line of standard base components being built, and then at the very end, the top crossbar of the T, it suddenly branches out into numerous customized options right before shipping.
Like building a standard laptop chassis and at the last second adding localized power cords or
Right.
upgraded RAM for specific orders.
Exactly.
And I'm assuming the I shape is just continuous, standardized flow, like a soup canning line. Raw materials on one end, standard cans out the other.
Right, very straightforward. But the problem occurs when your factory floor is physically laid out to support a T shape, meaning your customized parts are stored right at the end of the line. But then a massive influx of bizarre custom orders forces the assembly process to act like an A shape, requiring complex convergence of parts early in the build. Your inventory staging areas are now in the completely wrong physical location. Forklifts are driving backwards against the flow of traffic. The floor just descends into total chaos.
If we connect this to the bigger picture, how does a company's leadership know if their FAS is actually functioning or if the floor is secretly descending into that forklift chaos you just described?
They measure variance.
Variant.
Measuring FAS performance is all about identifying the frequency and the magnitude of deviations from the schedule.
So if you're constantly off schedule, something's broken.
If your FAS is constantly broken, managers are spending their entire day rapidly reprioritizing orders, cannibalizing parts from one order to save another, and basically begging customers for extensions.
That sounds incredibly stressful.
It is. If you are consistently missing the mark in FAS, it means your underlying assumptions are fundamentally flawed. You might need to make massive strategic shifts to your base inventory levels, invest in new machine capacity, or just extend your quoted lead times because your promises are disconnected from your physical reality.
Okay, let's take a breath and recap this incredible mechanical gauntlet. We started with the grand theoretical plans.
Yeah.
But to make them real, a company first runs capacity requirements planning, CRP. That's the detailed, infinite loading simulation to spot the icebergs and verify if the factory has the physical muscle to do the work.
Exactly.
Then we move outward to the customer with ATP, available to promise. That's the strict mathematical firewall that intentionally ignores forecasts to ensure we only make promises based on firm inventory.
The reality check.
And finally, when the order drops, we hit FAS, final assembly scheduling, the rapid sequence of bottleneck checks and floor coordination to deliver that exact product on time without causing forklift chaos.
It is a phenomenal synchronization of disparate data sets.
Right.
But this raises an important question, something the literature is pointing toward that will fundamentally upend everything we just discussed.
Oh, really?
Yeah, we talked about how CRP, ATP, and FAS are three distinct sequential pillars. But the integration of the Internet of Things and artificial intelligence is destroying the walls between them.
You're talking about the fully autonomous smart factory.
I am. Imagine a scenario tomorrow morning. An IoT sensor on a robotic welding arm detects a microscopic vibration in a joint.
Okay.
It instantly calculates that a 15% slowdown in output is imminent within the next hour.
Wow.
That sensor does not wait for a weekly CRP report to flag a bottleneck. It instantly communicates that capacity drop directly to the sales team's ATP system in the cloud in real time.
So it bypasses the planning phase entirely.
Completely. The ATP system immediately adjusts the available inventory and pushes delivery dates back for salespeople currently on the phone. And at the exact same microsecond, an AI autonomously rewrites the final assembly schedule for the afternoon shift to route custom orders away from that failing robotic arm.
Wow. So the distinct historical walls between long-term capacity planning, customer promising, and final assembly just dissolve completely.
Yeah.
It's no longer a sequential batch process. It becomes one living, breathing nervous system.
Exactly. The underlying mathematical principles of capacity, availability, and scheduling, they don't change. But the speed of the math goes from days down to milliseconds.
Which fundamentally changes how you have to look at the world around you. Thank you so much for joining us on this deep dive today.
My pleasure.
I highly encourage you, the listener, the next time you are online and you click buy on a customized pair of sneakers or new electric bike,
Yeah.
just take a second to look at that delivery date flashing on your screen.
It's not just a guess.
No, it's not. Appreciate the sheer volume of data, the capacity simulations, the finite math, and the assembly choreography that had to execute perfectly in a fraction of a second just to make you that simple promise.
The physical world is constrained, but the systems we build to control it are constantly evolving.
So true. Until next time, keep diving deep.